Hey, hello class. So today we're going to be talking about inverse trig functions and how to evaluate them. So the first thing is to understand really what in the world is actually happening. So for a trig function, what we do is we input an angle, and then the output is a ratio, or you can call it a value. And for inverse trig, you input the ratio slash value, and then what it gives you is the angle that makes that happen given the trig function. So for instance, over here, we have sine inverse of negative 1/2 equals what? This means sine of theta equals negative 1/2. What is theta? Well, if we look at the unit circle, we can kind of get a bit of a hint for that. Here we see that in order to make sine equal a half, or negative a half, there are actually negative a half, right? Yes, negative a half. There are actually two angles that make that happen. We get, not 5 pi over 6, 7 pi over 6, and 11 pi over 6, otherwise known as negative pi over 6. So, what is it going to be then? Is it 7 pi over 6, is it 11 pi over 6, negative pi over 6? That's the question we're trying to answer here then. So, we're going to actually need to restrict this so that we can do that. So, let's do that exact thing and see how we're going to restrict it. So, the range restrictions for sine inverse are going to be, basically, we need to be able to get from negative 1 to 1. So between negative 1 and 1. So we need to find angles so that also the result is going to be a function. So the thing that we're going to want to do is go from negative pi over 2 to pi over 2. The reason for that is because this part of the curve does cover everything, actually. And it's just the most central one. By central, I mean closest to 0. So the range restriction for sine inverse of x is from negative pi over 2 to pi over 2. So range deals with the y values, right? So this is going to be y instead of x. Okay, so then what about cosecant inverse? Well, let's see. We need basically from 1 and on and from negative 1 and on. So we have this area and this area. Essentially what we could do is just take this part and just choose those. So basically the range restriction is going to be from negative pi over 2 to 0, and then 0 to pi over 2. We don't include 0 because of the fact that 0 is undefined. We got an asymptote there. So write these down, know them. They're going to be useful for everything from this point on. Alright, changing to the next one now. Actually, I'm going to copy this thing so that I don't have to keep writing it, because it's almost going to be the exact same type of thing for every single one of these. So okay, here we have, okay, stop moving. Okay, there it is. And then we're just going to do the same exact thing, except we're going to do it for the other trig graphs. Or inverse trig graphs, I guess. Okay, so if we think about the cosine one, we see very similar things happening, right? I know I'm not showing it here as I'm talking about it, I'm just... yeah. So what we get is we want the cosine to be restricted between 1 and -1. So like here's -1, here's 1, here's -1 again, and we want to choose the most central one, right? But there are two that are central. There's this one, and there's this one. They're equally central. So which one do we choose? We choose the one that is positive. There's no special reason except for the fact that it's positive, so literally, why not? So, yeah, people have just decided to do that because it's positive. We like positive, so yeah. Cosine inverse of x, the restriction is going to be from 0 to pi. So any angle that you choose for the solution to cosine inverse of x is going to have to come from 0 to pi. And then for secant inverse of x, it's going to be, we're basically just going to do the same exact thing. Because it actually makes sense. Because it's going to cover all of the values the secant inverse is going to need to cover. The value that's going to skip, though, is pi over 2. So it goes from 0 to pi, skipping pi over 2. Alright, so write that down, take a picture, whatever you need to. I'm going to change it now so that we can move on to tangent. Okay, for tangent, we're going to have some interesting stuff going on. One of the main things is we're actually not going to have equal to signs, because for tangent inverse, if we just look at the tangent graph, we have these asymptotes, right? So it repeats and does the same thing every single pi after pi radians, and we're just going to choose the most central piece and essentially restrict it that way. If we do anything between -pi over 2 and +pi over 2, we'll get every single possible angle and value for tangent. So it's going to be from -pi over 2 to pi over 2, not equals. That is very important because you cannot equal an asymptote. You will be marked wrong if you put the equal to sign here, because it's not correct. So it's wrong. Okay, so write that down if you need to. I'm going to change it right now. You can pause as well. Alright, cotangent inverse of x. Similar thing. We're going to use the positive part of 0 to pi over 2. I mean pi. Why did I say pi over 2? Because it's just the same exact reason that we used it for cosine inverse. So as you can see, basically the restrictions are either going to be from -pi over 2 to pi over 2, or from 0 to pi. So if you know the parent graphs, it helps you with understanding and remembering all of that stuff. Alright, so let's practice this. So sine inverse square root of 3 over 2. So we know that's going to be one of the pi over 3s. This thing is positive, so it's going to be positive pi over 3. Cotangent of square root of 3. We know the cotangent is square root of 3 at the pi over 6s. It's positive, so this is going to be at pi over 6. Tangent inverse of -1. Tangent is going to be 1 at the pi over 4s. This is -1, so this will be -pi over 4. Secant inverse of square root of 3 over 2. Actually, that doesn't make any sense to do. Let's do 2 over square root of 3. Whoops. Because it's secant. Okay, so this means, well, cosine is square root of 3 over 2 at the pi over 6s. So secant inverse is going to be the same thing at those places. So it's going to be pi over 6 because this is positive. Okay, cosine inverse of -1/2. This is going to be at the pi over 3s. This is negative, so it's going to be at 2 pi over 3. Secant inverse of -2 is going to be, let's see, cosine of 2 pi over 3. Cosine of 2 pi over 3 is going to be 2 pi over 3. Secant inverse of -2 is going to be 2 pi over 3. Secant inverse of -2 is going to be 2 pi over 3. Secant inverse of -2 is going to be 2 pi over 3. Secant inverse of -2 is going to be 2 pi over 3. what equals negative 1/2? Oh, the thing right up there. So it's going to also be at 2 pi over 3. Okay, cosecant of negative 2. So sine is negative 1/2 at negative pi over 6. So that works there. And then tangent inverse of negative square root of 3. That's going to be at, let's see, so tangent is square root of 3 at the pi over 3's. So this will be negative pi over 3. All right, so this isn't too difficult. It just takes a little bit of extra thinking because of the restrictions thing. But the restrictions thing does make it a little easier, because then you have very specific things that you can look at rather than literally every possible thing. All right, and then we're going to learn how to graph these in the next video.